बिग बॉस चाहते हैं कि सब अपने अपने स्कोर्स बताओ। बिग बॉस चाहते हैं, सूरी सर नहीं चाहते। हाँ, मैं ये देखना चाहता था कितने लोग बिग बॉस देखते हैं, इसीलिए तो बिग बॉस, बिकॉज यू आर नॉट एबल टू सी मी। क्या बात है, सभी लोग 90% प्लस ही दिख रहे हैं मुझे। भाई कोई है मेरे जैसा, लेस देन 80% है कोई? इज देयर एनीवन लेस देन 80%? 33, 70? ये है मेरे दोस्त, दीज आर माय फ्रेंड्स, माय रियल फ्रेंड्स। नहीं, तुम लोगों के मार्क्स देख के तो मैं डिप्रेस हो जाऊंगा। 95, 99, 98, इतनी तो मेरी अटेंडेंस भी नहीं थी। ओके, चलो कोई बात नहीं, सब पास हो गए ना, सब आ गए ना 11 स्टैंडर्ड में ऑफिशियली एवरीवन। अटेंडेंस रिजल्ट से कम है। चलो भाई, बहुत बढ़िया, ठीक है, चलो स्विच ऑफ करता हूँ चैट को, ताकि मैं तुम्हें बता सकूँ मेरे कितने थे। ओके, तो पहले तो बताता हूँ कि मैंने इन विच ईयर आई अपियर्ड फॉर 10th स्टैंडर्ड। ओके, 10th स्टैंडर्ड, दिस इज मेरा रिजल्ट आया था इन 2002। दिस इज द ईयर व्हेन आई गॉट माय रिजल्ट्स फॉर 10th स्टैंडर्ड। पहली चीज़ तो ये, ठीक है। एंड ऑब्वियसली यू वुड वांट टू नो कौन से बोर्ड से सर थे, तो सीबीएसई बोर्ड से था मैं, है ना। एंड हाँ, यू वर नॉट इवन इंसेप्टेड बाय दैट टाइम, है ना। एंड स्कोर मेरा स्कोर था 77.8%। दिस वाज मी। नहीं, व्हाई वुड आई लाई, दिस इज फैक्ट। तो मैं इसको राउंड ऑफ करके जरूर बताता हूँ 78%, बट एब्सोल्युटली दिस इज द ट्रू स्कोर। ठीक है, अच्छा चलो अभी स्टॉप राइटिंग, स्टॉप राइटिंग। ओके, हैव यू पास्ड द 10th स्टैंडर्ड, बस इतना बता दो, हैव यू पास्ड 10th स्टैंडर्ड और नॉट? आई विल बी 35 years old this year. I don't look like I know that. क्या बात कर रहे हो यार, so many people clicking on no also. अरे tell me, the question is have you cleared 10th standard or not with the present results? तो अगर how did I made it to IIT बॉम्बे, सिंपल ना, जेईई का एग्जाम क्रैक किया ना, उसमें 10th स्टैंडर्ड की परसेंटेज का क्राइटेरिया नहीं था अभी, 12th स्टैंडर्ड का भी नहीं था। 12th स्टैंडर्ड का था, 65% मार्क्स चाहिए थे 12th में, तो उतने आ गए थे 12th में। चलो गाइस, लास्ट 5 seconds for you to respond. The hotspot is about whether you cleared 10th standard or not. 5, 4, 3, 2, 1, that's it. क्या बात है यार, तुम लोगों ने तो डरा दिया भाई। ये जो 7.75% लोग हैं, ओके, ये जो 7.75% लोग हैं, इफ यू गाइस, आई डोंट नो व्हाट डू आई टेल यू। हाँ हाँ कैप्टन अरशद, बोलिए क्या किया जाए, आपकी बात तो सुन ली हमने, तो क्या चाहते हो, सूरी सर क्या करें अब? कैप्टन अरशद, व्हाट डू यू वांट सूरी सर टू डू? ठीक है, तो चलो यार बाकी की बातें आफ्टर द क्लास करें, बाकी डिटेल में बात करते हैं आफ्टर द क्लास, व्हाट डू यू से? ठीक है, लेट्स स्पीक एट द एंड ऑफ द क्लास, अदरवाइज हम पढ़ नहीं पाएंगे। आई नो आज बहुत सारी इमोशंस हैं, तो इमोशंस को थोड़ा सा काबू पे रखते हुए, कंट्रोल करते हुए, लेट्स start the session. Towards the end of the session, if you really want to speak to me, stay back. Okay, give me a +1 if you understand. Quickly, give me a +1 if you understand. Very nice. Thank you so much. Let's continue. That's more like my students. Thank you so much. And meanwhile, you have your class teachers also in the class, Arun sir and Gautam sir. So quickly say hello to them also. Arun sir and Gautam sir, say hi to your class teachers quickly so that we can start. This is our 5th and the last session of work by energy. And after this session, we'll move to circular motion. Okay. Very good. Very good. Thank you. Awesome. Hello. Okay guys, switching off the chat now. Thank you. Hello class teachers, welcome to the class. Let's have a quick recap of what we did last time, and today's discussion eventually after that will revolve around the last part of the chapter, that is power. We have already understood the discussion of work and energy. Last time we spoke about kinetic energy and very important work energy theorem. So we understood something which we already knew. We had a recap of kinetic energy, one of the few formulas which are still the same. Kinetic energy of a body is given by half mv square, and assuming mass is constant. And in that case, if v is changing, kinetic energy will be changed as per the speed of the body. And importantly, kinetic energy is scalar, so v square will always be positive. So kinetic energy will always be positive. And then we looked at two expressions which some of you already were aware about. That is correlation between momentum and kinetic energy. Okay, so a few problems also solved on this, and then we move towards very important discussion of the chapter called as work energy theorem, which is another way of talking about law of conservation of energy. It said that the total forces which are working in a system, if you find out the work which is done by all of them individually, work done by all the forces, if you calculate them individually, add all the work, that value will always come out to be equal to change in kinetic energy. Okay, and if you say that there is no non-conservative force working, and only if there is no conservative force working, there is no gravity, there is no electric force, there is no magnetic force working, then if your non-conservative forces are still working, if external forces are still working, then there will be a change in the overall mechanical energy of the system. That's what point number last says. If non-conservative forces act in the isolated system, the total energy of the system is conserved, although the mechanical energy will not be conserved. That simply means what? Non-conservative forces, I told you the definition, they will try to change the mechanical energy of the system, but overall energy of the world will remain the same. Energy can neither be created nor be destroyed, it remains unchanged. But if your conservative forces are working, then mechanical energy will remain conserved, only kinetic will change to potential, potential will change to kinetic. That's what we learned last time. Okay guys, so quickly taking you all for a few quiz questions. Here's our question number 1. Based upon the previous session, obviously, a force is acting on a 30-gram particle in such a way that the position of the particle as a function of time is given by this expression. So this is how the position is changing. If you differentiate it once, you will get velocity. If you differentiate it twice, you will get acceleration. I'm giving you an additional information. You may or may not require it. You have to find out the work done in the first 4 seconds. That means between t equal to 0 to t equal to 4 seconds, how much amount of work was done by the forces which are acting on the body. Giving you all 90 seconds. Okay, and looking at the option, I'll give you 2 minutes, and your time starts in 3, 2, and 1. 50 seconds remaining. Okay, now approaching the last 10 seconds, everyone. And the time is up. So I gave you guys that additional time because maybe the calculations were involved. That is why. Good to see that the top 10 people, majority of you guys got this right. So very simple, guys. The work done is equal to the change in kinetic energy. So all I need is half m v2 square minus v1 square. That means I need the expression or value of velocity. So because x is given to us, I can easily find out how velocity is changing with time, and that will come out to be 3 minus 8t plus 3t square. Right, everyone? That's the differentiation you got. 3 minus 8t plus 3t square. Plus 1 in the chat box. Right? Good. So at t equal to 0, the initial velocity is 3 meters per second. And how much you got at t equal to 4? Need your help with this. Itni maths meri achhi nahi hai. My calculations are not good. So this comes out to be how much? Need confirmation from multiple people. 90. Chalo, theek hai. Trusting on you guys. So then there is nothing else to do. The work done is equal to change in kinetic energy. That is equal to half into mass of the body. That is 30 into 10 to the power minus 3. Because grams hai, kg mein convert kiya. And then 19 square minus 3 square. And when you simplify this, it should come out to be 5.28 joules. Nearly 5.28 joules. Right? That's what it will be. 30 gram hai na? Mass of the body. You did integration. बाप रे, differentiation करना था. Okay. सवाई यार पोजीशन का इक्वेशन दिया है ना. Okay. What is 19 का स्क्वायर? मतलब ये भी सुई सा बताएं कि 19 का स्क्वायर क्या होता है? 361 it is. So now the question is, the real question is, can we not solve this by f into s? Can we not solve it by f into s? If you will try that, it is given to us that x is 3t minus 4t square plus t cube. Minus 4t square plus t cube. So if you differentiate once, you will get velocity. So why? When you differentiate position or displacement, you get velocity. So that came out to be 3 minus 8t plus 3t square. You differentiate it one more time, you will get acceleration, which will be minus 8 plus 60. So is it a constant? Is it a constant? Definitely, it's not a constant. So if this is not a constant, the force which is mass into acceleration will not be a constant. तो वैसे ही क्या कम लाइफ में प्रॉब्लम्स हैं जो तुम अपनी प्रॉब्लम्स और बढ़ाना चाहते हो? So we cannot solve like that. So this is one of the things. You will still be able to find out force as a function of time. No problem with that. You will just have to put a ka expression here and mass ka value as 30 into 10 to the power minus 3 kgs. But the problem is when you want to integrate to find out the work done, my force has to be a function of displacement, and this is not given. I have not been given the force as a function of displacement. Getting? So even if I get the value of force or expression of force, I'm still stuck. Getting? यहाँ समझ में आ गया ना सबको? तो मैं प्रीवियस स्लाइड दिखाता हूँ. लो भाई प्रीवियस स्लाइड देखो और खुश हो जाओ. सर मेरे को समझ नहीं आता कि कहाँ इंटीग्रेशन करना है और कहाँ डिफरेंशिएशन करना है. ये चीजों का ज्ञान हमने दिया था काइनेमैटिक्स चैप्टर में. तो गो टू मोशन इन वन डायमेंशन सेशन नंबर 5 और 6 से मैंने रिज्यूम किया था. वहां से देखना शुरू करो नोट्स को. यू विल फाइंड इट आउट व्हेन आई हैव टॉट यू पीपल योर नॉन यूनिफॉर्मली एक्सेलरेटेड मोशन. वहां पे मैंने टेबल बना के बताया था. ओके, तो थोड़ी बहुत मेहनत तो खुद से करना पड़ेगा तुम्हें. सब चीजें ऑलरेडी कुक तो होंगी नहीं. ओके, सो इफ यू हैव इक्वेशन व्हिच इज डिस्प्लेसमेंट एज अ फंक्शन ऑफ टाइम, वेलोसिटी एज अ फंक्शन ऑफ टाइम और एक्सेलरेशन एज अ फंक्शन ऑफ टाइम, इस इक्वेशन को अगर तुमने डिफरेंशिएट किया तो क्या होगा और इंटीग्रेट किया तो क्या होगा. इस इक्वेशन को डिफरेंशिएट किया तो वेलोसिटी मिलेगी, इंटीग्रेट किया तो टाइम पास होगा, कुछ नहीं मिलेगा. अगर एक्सेलरेशन की इक्वेशन को इंटीग्रेट किया तो चेंज इन वेलोसिटी मिलेगी, यू विल गेट चेंज इन वेलोसिटी. बट अगर डिफरेंशिएट किया तो फिर से टाइम पास होगा, कुछ नहीं मिलेगा. बट सबसे इंपॉर्टेंट इक्वेशन है वेलोसिटी और टाइम. ओके, इफ यू डिफरेंशिएट वेलोसिटी इक्वेशन यू विल गेट एक्सेलरेशन, इफ यू विल इंटीग्रेट वेलोसिटी इक्वेशन यू विल गेट डिस्प्लेसमेंट. ठीक है, so this is what it is. I have done this a number of times now. ठीक है, सर मैंने इंटीग्रेट करके सवाल बनाया और आंसर आ गया, तो इसे हम बोलते हैं फॉर्चुनेट मिस्टेक। हम कहते हैं इसे फॉर्चुनेट मिस्टेक, कि गलत मेथड लगाया और आंसर आ गया। ठीक है, ये बिल्कुल ऐसा है कि क्रिकेट में खेलने तो हुक शॉट जा रहे थे, लेकिन वो शॉट जो है वो हुक शॉट ना जाके कुछ तो पुल शॉट बन गया, एज हो गया और सिक्स चला गया, तो मार्क्स रन तो मिल जाते हैं, लेकिन यू नो दैट कि करने वो नहीं गए थे। बिल्कुल ऐसा ही। ओके cool, चलो बहुत टाइम पास हो गया ऑलरेडी, लेट्स गो फॉरवर्ड, दिस इज डन। नेक्स्ट क्वेश्चन इन फ्रंट ऑफ यू गाइस। An object of mass m is released from the rest from the top of a smooth inclined plane. Remember, question is talking about a smooth inclined plane of inclination theta. Okay, this is frictionless, and you have a block which will be released from the top of the inclined plane. The height of the inclined plane is h. So when the block will reach here, just at the bottom of the inclined plane, its speed will be proportional to m to the power 0, 1, 2, or minus 1. That's what you have to find out. Giving you all 60 seconds, and your time starts. 3, 2, and 1. Come on, guys. Are we done? Last 5 seconds, everyone. And the time is up. Let's see. Now this was easy. This is something that we have done already. Okay. ये क्वेश्चन में एक्चुअली सॉल्व कुछ नहीं करना था, अगर एक्चुअली दिमाग से सॉल्व करते, if you had actually thought of it from common sense. We know that. Do we know that the acceleration of the body on inclined plane? What is the acceleration of a body on the smooth inclined plane? Is it g sin theta? G sin theta, right? Does it depend on the mass of the body? In fact, I told you guys, you make an elephant come down or you make a mosquito come down a smooth inclined plane, they will take the same time, right? So when they are taking the same time, when they are accelerating by the same value, then their velocity will also be same, independent of the mass. But still, if you want to try this, you will say that, okay, which force is bringing the body down? It is mg, right? So can I say that? Do you guys remember? As long as the level by which the body is coming down is same, the work done will be eventually mgh only. Can we say that directly? The effective loss of potential energy. Let's look at it from common sense once again. The loss of potential energy should be equal to the gain in kinetic energy, because there is only conservative force working on the body. There's only conservative force working. What about friction? वाह, मेरे सुपर डुपर वूपर ऑब्जर्वर, मतलब जब मैं चिल्ला चिल्ला के बता रहा हूं दैट द सरफेस इज स्मूथ, अपने खुद के पर्सनल हाथों से अपनी खुद की पर्सनल हैंडराइटिंग में लिख भी रहा हूं फ्रिक्शनलेस सरफेस, फिर भी हम पूछेंगे कि फ्रिक्शन का क्या होगा? हां, सो द लॉस ऑफ पोटेंशियल एनर्जी is equal to the gain in kinetic energy. So can I say that the overall loss of potential energy here is how much? mgh, right? And overall gain in kinetic energy is how much? Half mv square. If you want to write the change, you can do this also. You can see that m is getting cancelled. So v is equal to 2gh in under root, which is basically m to the power 0. Does not depend upon that. Okay. Good enough. अब कुछ लोगों की जनता डिमांड पे ये भी कर देता हूँ that work done should be equal to the change in kinetic energy. Okay. So work done is mg sin theta into L, which is equal to half mv square. अब कुछ लोग चाहते हैं कि सर ये वाला क्यों नहीं हो रहा ऐसा? वैसे तो आंसर यहाँ से भी आ रहा है कि m और m कैंसिल हो गया, इंडिपेंडेंट ऑफ मास हो गया, बट मैंने पहले भी बताया था, if this is the length of the inclined plane in this triangle, what will you write sin theta as? How will you write sin theta? How will you write sin theta? It is h by L. So can I say that h is equal to L sin theta? लिख सकता हूँ ना? तो यहाँ देखो, what is L sin theta? What is L sin theta? It is h only. So what are you writing? mgh equal to half mv square, and super duper magic once again, the same equation, mgh equal to half mv square. Okay, ठीक है. बैकग्राउंड साउंड ऑफ फैन नहीं है, वो बैकग्राउंड साउंड ऑफ एयर कंडीशनर है, बट आई एम स्विचिंग इट ऑफ. लो, हैप्पी? चलें एवरीवन, लेट्स स्टार्ट द सेशन. हाफ एन आवर इज ऑलरेडी गॉन. रिकैप से ज्यादा तो टाइम चला गया हमारा उसी में. यप, चलो देन द लास्ट पार्ट ऑफ द सेशन और द चैप्टर, इट्स पावर. Okay, so broadly we'll speak about power, and we'll speak about a specific type of questions where we will be lifting objects, we'll be lifting water, a pump will be sending water from ground level to a certain level, how much amount of work will be done per unit time. So I hope all of you guys know the story of power. Power is not about how much work is done. Okay, that's okay guys, no problem, I'm good. Power is not about how much work is done, it is about how fast the work is done. It's not only about how much work is done. If same work is being done by two people, and say they are lifting a block or a box, they are taking it from ground floor to fourth floor, both of them are doing the same thing. Okay, but when they are doing this, one of them takes say 5 minutes, the other one takes half an hour. So will you say that the same amount of work is done? Yes, the same amount of work is done. But what is not same in both of them is the time in which they are doing it. Okay, everyone. So we will say that the power is basically the work done per unit time. Means what? Power is the quantity that we are defining as the quantity which will tell us how effectively the work is being done, how efficiently the work is done, or how fast or how slow the work is being done. If you take it to instantaneous level, this is the average level that you see. The amount of work done, amount of time taken. This is average power that you understand. But if you take it to instantaneous level, the differentiation or calculus will come into picture. You will be able to write it as dW by dt. That means what? If by any chance you are able to plot a graph between work and time, and that's how this comes out to be, then on that graph, if you say draw a tangent at a given point, then at that point how fast the work is being done can be calculated. So this is basically the slope of work and time graph, and vice versa also. If you have a graph between power and time, and you want to find out the area of that graph, the area of that graph will be equal to the work done. I hope you guys are able to figure this out. Okay, so formally introducing it once again, the power of a body is defined as the rate at which the body can do the work, or the rate at which energy is converted from one form to another. Eventually work is nothing but conversion of energy from one form to another. So average power, as I said, is w by delta t, total amount of work done divided by the total time taken. But if it is happening instantaneously, then it is dw by dt. Small amount of work done can be written as f dot ds by dt. And if you are paying close attention, then have a look at this. What is ds by dt? It is nothing but velocity. So interestingly, this part if I write as velocity, power is nothing but dot product of force and velocity. It's a very interesting and very important formula to keep in mind. Other formulas are very obvious. This is the one which you will be able to use when force and velocities are given to you. Okay, and because it is measuring the rate at which work is done, so definitely power is also a scalar quantity. It's SI unit and everything will write on the next slide. But again, just to reinforce what I said, remember that power is the measure of how fast or slow the work is being done. Okay, and also we know that work done is nothing but change in kinetic energy. From work energy theorem, we learned it last time. So we can also say it is rate of change of kinetic energy per unit time, and we can always use the same approach of finding the graph, the area and the slopes, which we talked about. If you plot this for kinetic energy and time, then also the situation will turn out to be same. Okay, so that was done. Maybe some of you are noting it now. Not entire thing you'll have to note down. Okay, I'll remove this in next 5 seconds. 5, 4, 3, 2, and 1. Okay, don't worry. Whenever the question will require it today, I will give you the formula also. So everyone, as power is work upon time. If you talk about SI unit of it, the SI unit is joule per second. But you can say, giving the respect to the person who studied power for the first time, James Watt. So what is the SI unit of power? How about dimensions? The dimensions are m1 L2 t minus 2 divided by t, means work upon time. So the dimensions will be m1 L2 t minus 3. These are the dimensions of power. And the nature of the unit, nature of the quantity, absolutely a scalar quantity. Okay, so we understand this so far. Yeah, so okay, they have also spoken about it. I didn't know that. So the units are given, CGS unit and other units are given, kilowatt hour, kilowatt, megawatt, horsepower, and all these. Horsepower is a, you can say, commercial sometimes, or you can say more of a industrial unit. Horsepower is the industrial unit. Especially the automobile industry talks about power in horsepower. Means usually try to compare how powerful a car is with a horse. The 1 horsepower, 2 horsepower, name suggests comparing with how many horses the work is equal to per unit time. Okay. Also, everyone, whenever we talk about the unit kilowatt hour, this is called as 1 unit of electricity. When your electricity bills come, or if you will, ask for the electricity bill of your own house for previous month, it always talks about the number of units consumed in this month. The number of units are basically the number of kilowatt hours. Kilowatt into hours. That means number of kilowatts consumed every hour. So if you have that number, that is telling you how many units of energy is being consumed. So remember, kilowatt hour is not the unit of power, it is the unit of work and energy, because kilowatt is already power and multiplying it by time will give me the value of work or energy. So don't get ever confused with that. Okay, so you can always find out how much 1 kilowatt hour is. So 1 kilo is 10 to the power 3 and 1 hour has 3600 seconds. So 3.6 into 10 to the power 6 joules is 1 kilowatt hour. That is basically 1 unit. This much unit when you consume in Mumbai, the rate of calculation of the bill over 1 unit is 8 rupees. Per unit that you consume for electricity in Mumbai, you pay 8 rupees to the government. So imagine the bill and number of units that you consume every day, right? Or every month in fact. Okay, now the part which I explained you already. If you have work and time graph and you find out the slope of that graph at any point, you'll be able to find out the instantaneous power. And if you integrate and find out the area bounded by power and time graph, okay, if you have a graph drawn between power and time, and if you find out the area, okay, so the area will represent work or change in kinetic energy as well. Okay, let's try to understand these better with the help of examples, everyone. So let's have a look at this one. The first example is ideally not supposed to be here, but I'm still not removed it. I'm keeping it. You will find it getting related with the second topic more. The second topic speaks about power required in lifting the water through a height h. So first question is actually related to the second topic, but we are still doing it. It says that the lift is designed to carry. Oh, sorry, I've actually taken it down, I guess. I've taken that question down. Fine. So when that question will come, I'll tell you. So this question is simple. It says that the lift is designed to carry a load of 4,000 kg through 10 floors of building, averaging 6 meters per floor in 10 seconds. Means what is happening? Say you have a building and it has multiple floors. First floor, second floor, third floor, fourth, fifth, sixth, seventh, eighth, ninth, 10th, so on and so forth. So this is your first floor. This is your 10th floor. And the average gap between the floors is 6 meters. So for 10 floors, it is 60 meters ka gap. Okay. And your lift is designed to carry a 4,000 kg ka load in 10 seconds. Okay. We have to calculate the amount of horsepower which is the lift is actually using in order to lift the 4,000 kg block. So basically, I need to find out how much amount of work is being done and how much amount of time is being taken to do that work. So we can easily calculate that. I think work will be equal to mass, that is 4,000 kgs, multiplied by g. If options do not suggest anything, and if the question is not giving you the value of g, and looking at the options ka gap, I will use g value as 10. Though I'm sure in the solution you'll find it using 9.8 also. And height of the total height is 10 floors. As the total height, that is 60. So h total, which we'll be using, divided by the time value is given to us as 10 seconds. Okay guys, so let's have a look at the solution directly. So total amount of work done divided by the total time taken. So as I said, they will be using 9.8. You can still work with 10 instead of using 9.8. You will get the answer very close. So 4,000 into 10, this gives me the value of mg multiplied by 60 meters divided by the time, that is 10 seconds. This gets cancelled. And when you simplify this, without this value, what you will be getting is the value in joules. I hope all of you are aware about this. If not, then from here you will remember this, that 1 horsepower, or HP in short, is equal to 746 watt. Means on an average, we say that 1 horse, when works, delivers 746 joules per second. This much amount of work is being done. So when you calculate the work only by multiplying these 3 factors, you will get the answer in joules. So you want to find out the work in horsepowers. Yes, Akash. Just a second. Yes, Akash. Yeah. Hello. Yes, tell me. Abhi? Fine. Then in the question, ideally the question will give you the value of g. Okay. If the options can satisfy with both g 9.8 and g10, then the option will only be satisfied with the given value of g, and question will definitely give us the exact value of g. Okay. So here I'm assuming that g value is given as 9.8 then. Okay. Thanks for confirming. Okay, guys. So as Akash said that, sir, if you take g value as 10, then the answer doesn't come as 315, it will come out to be 320. So I'm not getting into the verification of that. But what I'm trying to suggest you guys, that the question will in such cases give you the value as 9.8 meters per second square. So let's go forward. When we multiply, we will get the value as this in joules. So in order to find the answer in horsepower, I will divide it by 746 and the answer will come out to be in horsepower here. Okay, everyone? Hope it is clear and easy for you to understand. Everybody's clear with the idea? If I know 1 horsepower is 746 joules, or let me put it this way, if 746 watt is 1 horsepower, then 1 watt is equal to 1 upon 746 horsepower, right? So you multiply whatever value of what you want to convert into horsepower. That's why we divided by 746. Okay, he was right. That's good. Fine, then G value 9.8 will be used. Chalo then, question for all of you guys. Okay, very less theory once again today also, and you will have only problem solving happening. That's the best part about mechanics, is this very less theory, a lot of problem solving. So guys, question in front of you says that we have two people, mass, the person M1 has mass 80 kgs, and he will do a work by running up on a staircase in 15 seconds. This is his mass. Another person, M2, also has the same mass. He will also run up by the same staircase and the same distance, but he is going to take 20 seconds. So what is the ratio of the power developed by them individually? So mass is same height is being covered. How much power will be delivered? P1 is to P2. That ratio is being asked, giving you 45 seconds, and your time starts in 3, 2, it's work upon time, and 1. Power is work upon time, everyone. Okay, that's good. So guys, if we look at power is basically mgh by t, because in this process the person is effectively going to increase its potential energy while going up. So all in all, if we look at the factors here, mass is same, g is same, and h is also same. So these three factors are common, so they will not play any role in comparison. So it is this time for which you will be able to compare it. So that means P1 by P2 should be equal to T2 by T1. Second object or second person is taking 20 seconds, first person is taking 15 seconds. That very easily gives me the answer as 4:3, and that's our answer. Okay, everyone? Cool. Awesome. Another one. Now this one is a real good question, and I want you people to very patiently read the question, try to understand this. It says that we have an elevator which can carry a maximum load of 1800 kgs, elevator plus passenger, and it is moving up with a constant speed of 2 meters per second. So the friction force is opposing the motion, and it is given to be equal to 4000 Newton. That means inside this duct, you have your elevator. This elevator is going up. While this elevator is going up, it is experiencing a frictional force. That frictional force is given to us as 4000 Newton. So question is asking us to find out the minimum power that is delivered by the motor of the elevator. So definitely your elevator has a motor connected in it, which is applying a force upward. That force is doing some work per unit time. So what is the power delivered by this one? So how much power is delivered by this is what you have to find out. The lift is moving with a constant velocity, which also means that its acceleration is 0, giving you full idea about this thing. Giving you guys 90 seconds to solve this. Your time starts in 3, 2, in 3, about this thing. Giving you guys 90 seconds to solve this. Your time starts in 3, 2, and 1. Kinetic energy of the object is constant. It's not changing. So work is done in order to increase the potential energy only. Okay. Okay, Deepan Saha. Take care, bacha. Take care. No problem. No problem, Deepan. $35 seconds remaining. Last 5 seconds. Let's see. The biggest mistake which happens in this question is we understand that acceleration is 0. So definitely the net force acting on the object is also 0. So that we assume that capital F will be equal to force of friction. How many of you just did this? How many of you thought the force applied by the lift motor is this? Is your lift operating in gravity free space? Is your lift operating in gravity free space? There is one more force which is acting on the body. There is one more force which your external or motor force has to overcome. And this is the situation. The force that your motor will apply will overcome mg and friction both. Make sense? So this is 1800 into 10 plus 4000. So this comes out to be 22,000 Newton force. This is the force that is working. Okay, everyone? And how much the power will be? Power is F dot V. Remember this formula? F dot V. If not, you will say it is mgh by T, and it is mg, or rather not exactly mgh by T. You will say it is force into displacement upon time. This is what is work done, right? And what is S upon T? It is velocity. So 22,000 into 2 comes out to be 44,000 watt. Got it? That's 44 kilowatt. Now exact answer 44 किलोवाट. सर मैंने 22,000 तक किया था, तो उसके लिए नोबेल प्राइज तो नहीं मिलेगा, उसके लिए स्टेप मार्किंग भी नहीं मिलेगी. जेई का एग्जाम है, बोर्ड का एग्जाम नहीं है ये. यहाँ स्टेप के कोई मार्क्स नहीं होते. फाइनल आंसर करेक्ट होने पर ही. सर 9.8 यूज करते देन 35 समथिंग इज कमिंग. मतलब करते, बिल्कुल करते, लेकिन अगर तुम क्वेश्चन में ये बिना देखे करते तो डेफिनेटली टाइम पास करते. मतलब अगर तुम ये मान के चलते हो कि सूरी सर पूरा क्वेश्चन पढ़ेंगे तुम्हारे लिए, तुम नहीं पढ़ोगे क्विज में, तो फिर तुम जेई के एग्जाम में क्या करोगे? वहां कौन से सूरी सर आएंगे? हाँ हाँ, बोर्ड्स में तो स्टेप मार्किंग मिलेगी, बट वी आर नॉट प्रिपेयरिंग फॉर ओनली बोर्ड्स, वी आर आल्सो प्रिपेयरिंग फॉर जेई, राइट? चलो, मोर क्वेश्चंस. यस, नो प्रॉब्लम, हो जाएंगे सवाल. Next question. Now this is a real good question, but a question that will never come in JEE because it has already come in JEE. Okay, and a very good conceptual question. In the first attempt, it's very difficult to get this question, but after that, it becomes extremely easy. What the question is saying is that a body is moved along a straight line by a machine which is delivering a constant power. That could be seen as the lift, it could be seen as the car, or any object on which a machine is working and delivering a constant power. So first of all, constant power is basically what? It is force into velocity, which is given to us as constant. Okay, assuming that the angle between force and velocity is 0 degree. In such questions, we assume that. So let's say that the constant is k. Okay, question is asking us how displacement is proportional to, or how it is dependent on time. Pay attention how it is done. In order to find out displacement as a function of time, thank you Karthik, but now that's not my dream. Okay, so in order to find out displacement as a function of time, I need to somewhat think about this table. I want to find out displacement as a function of time. In order to have displacement as a function of time, if I have velocity as a function of time, I can integrate to get displacement. And in order to get velocity, if I have acceleration, I can easily do that. So somewhere I need to think about the kinematics or equations which are going to come from kinematics. But do I have the surety that my force is constant, or all the things which are given to me, are they suggesting that the force is constant? So far it doesn't say, it says only power is constant. Okay, so everyone look at the approach. If power is constant and we are saying that force into velocity is a constant k, then I can write down force as mass into acceleration into velocity, and that is equal to constant. This acceleration also I can write down as dv by dt because I want to find out velocity as a function of time, so that I can integrate to get displacement as a function of time. Okay, so you will write velocity as dv by dt, sorry, acceleration as dv by dt, and this is how the equation turn out to be. So guys, look at this. V dv by dt, I can write it as k by m. If mass is also a constant, then this k by m is also a constant. Let's call it k dash. We only need the proportionality, so that's why I don't care about what is the constant and what are the factors involved there. So guys, let's take dt on the right hand side. This dt will be taking it on the right hand side. So v dv will be equal to k dash dt, right? What should I do next now? Ab kya kare? Any suggestions? Integrate? Good. So this will be integrated and this will also be integrated. Integration of v dv and k dash integration of dt. Okay, so let's do the integration. Integration of v dv. Integration of v dv. Acha. Integration of v dv, and we will say that it is v square by 2, and k dash integration of dt is t, right? So v square is 2k dash into t, right everyone? So can I say v is equal to 2k dash in under root and t to the power half? ऐसा लिख सकते हैं? Can I write it like this? We can, right? And what is velocity? Can I write it as ds by dt? We can write it as ds by dt, which is equal to, अच्छा 2k dash को भी एक नया constant बोल देते हैं, and now I'm going to call it say n. 2k dash is now n, and t to the power half. So ds becomes n t to the power half into dt. अब क्या करें? Should we integrate one more time? Right? So let's take it to the next slide and integrate. Let's begin from here. So integration of ds will be equal to n. N is a constant. Huh? ds का integration s. This is n. Integration will be half plus 1 divided by half plus 1. That is n t to the power 3 by 2 upon 3 by 2, or 2n by 3 t to the power 3 by 2. So what will I say? S is proportional to t to the power 3 by 2. Got it? Back to back. Okay. In the first attempt, it is definitely challenging, and that's why in my 3-star rating, this is a 3-star question. You want to have a look at it when you are revising before the examination. Okay. Got it, everyone? Where we started, we wrote force as mass into acceleration. Means crucial steps. If I have to tell you the crucial steps, these are the crucial steps, and after that, these are the crucial steps. This is where turning point happens in the question. When you are able to write force as mass into acceleration, acceleration as dv by dt, and when you are thinking of writing velocity as ds by dt. And if you were able to get this, so where did the constant c went? We are assuming that the constant value is 0 in such questions because we are looking at proportionality. Okay, that's why we did not write plus c. Okay, we did not write plus c, or we can also think of it this way, that when time was 0, the body was at rest, and when time became t, body's velocity became v. So the definite integration happened. Similarly, same thing was applied here. When time was t, position was 0. When time became t, position became s. So constant taken care of. Okay, everyone? +1 if you understand this now. Okay, good. So answer is proportional to t to the power 3 by 2. This is the type solution of this thing. Yes. Okay, now another question which is on the similar lines. Have a look at this also, everyone. After this, you will have a quiz question. Question says that power supplied to a particle of mass 2 kg varies with time as p equal to 3t square by 2 watt. Here t is in seconds, and if the velocity of the particle at t equal to 0 is 0, then velocity of the particle at t equal to 2 seconds will be how much? So you have been given power as 3t square by 2, and question is asking us, after saying that at t equal to 0, velocity is 0, so at t equal to 2, the velocity will be how much? Let's see if you guys can try this. Giving you people this question to try. If you are able to get this, that will be great. Okay, setting up the quiz. Okay, giving you all 90 seconds, and your time starts in 3, 2, and 1. $50 seconds remaining. Last 15. Okay, and the time is up. Massive confusion between B and C, I guess. So hope you people remember that power is work done per unit time, and work done is change in kinetic energy. So we can also write it this way. So if power equation is given, then we can always look for doing this instantaneously. Means what? If I want to find out the change in kinetic energy per unit time, that is what is power. So change in kinetic energy is p dt. So if I integrate this thing, I'll be getting the change in kinetic energy. Already the question has told me that at t equal to 0, velocity is 0, and then definitely kinetic energy is 0. So if I get the value of final kinetic energy, I will easily be able to calculate the value of velocity. Once it's on my app, then I'll solve it. Is the concept clear? This is what you are supposed to think. Right? Good enough. Cool. So we just now wrote the power in terms of kinetic energy, took this dt on the right hand side, and change in kinetic energy becomes p dt. Okay, sir, your network is very bad. मतलब अनम्यूट तुम नहीं हो पा रहे हो तो नेटवर्क मेरा खराब है, तब तुम्हारी स्क्रीन पे मैं ब्लर दिखाई दे रहा हूँ तो नेटवर्क मेरा खराब है ना? मतलब मौसम तुम्हारी सिटी में खराब है, इंटरनेट तुम्हारा स्लो चल रहा है, लेकिन नेटवर्क मेरा खराब है ना? यस अंशु, यार कॉन्सेप्ट तो मैं पहले ही रिपीट कर चुका, एक बार और बता देता हूँ, जो मैंने यहाँ भी बताया था, दैट पावर fundamentally basic definition of power is rate at which work is done or rate at which kinetic energy is changed. So in this question, because question is not asking me to find out work done, it is asking me to find out velocity. So velocity is related to kinetic energy. So thinking about kinetic energy is going to help us. Okay, so that is why in this question I'm not writing only dw by dt. Means rate of work done is not only power, but rate of change in kinetic energy is also power. This is going to help me. Okay, so let's solve. I'm going to integrate and get the value of change in kinetic energy. Okay, so I have integration of dk, which will be equal to integration of p dt. Kinetic energy at t equal to 0 is 0, and at t equal to 2 seconds, the kinetic energy is what I'm interested in finding. So integration of dk is going to be k, going from 0 to k, and power is given to us as 3t square by 2. So 3 by 2 t square into dt, time goes from 0 to 2. ये समझ में आया अभी तक? Power को मैंने लिख दिया as 3t square by 2. So this is k, this is 3 by 2, and the integration of t square is t cube by 3. Okay, you want to write plus C, you can write down, but because it is definite integration, I don't prefer writing plus C, especially in JEE preparation, right? So this is 0 to 2, 3 and 3 cancels. I have 1 by 2, 2 cube minus 0 cube. That comes out to be 8 by 2, comes out to be 4. And what is final kinetic energy? It is half mass of the body is 2 and V square. समझ में आया? So 2 and 2 cancels, V square is equal to 4, V comes out to be 2 meters per second. Plus 1 in the chat box if you got it. Sir, can we use last question का concept? Last question का कौन सा concept use करोगे इधर? अभी यहाँ power constant तो बताई नहीं है. सबसे पहली चीज तो very first thing in this question, the one which we solved before this, it clearly said that the power is constant, and the question which is right now being done says that the power is 3t square by 2, which does not look like a constant to me. Okay. Ansh, I'm trying to unmute you, but not able to hear you. Yes, solution slide once again for you. Guys, one humble request. In the doubt panel, only ask doubt. In the doubt panel, only and only type your doubts. No time pass in the doubt panel. Okay? A strict warning and a humble request together. Okay? We are enjoying the session, that's good, but no time pass stuff on the chat, on the doubt panel. Okay? Are Mr. Ansh, please rejoin the session. Ansh Jha, please rejoin. Ansh Jha, rejoin. Class teachers, please ask Ansh Jha to rejoin. Okay, everyone, we got this. Sure. If you still have doubts about this one, either ask your class teachers or keep it noted, ask me at the end of the class. Okay, cool. Let's go formally do a quiz question for all of you. The power to be constant, for power to be constant, the force has to vary with speed as which of these? This one looks easy, giving you 30 seconds and your time starts. Power has to be constant. 3, 2, and 1. Last 5 seconds. Okay. This was obvious. This was really very obvious. If power is force into velocity and this is a constant, then can we not say that, and let's say this constant is k. So force is basically k by v. So force is proportional to 1 by v. Isn't it obvious? The correct answer. Okay. Hope you guys understood. Sure. Let's move on to the next part of the session where we'll speak about power required in lifting water through a height h or any object to lift it through a height h without giving it any kinetic energy. So if you are lifting any object of mass m to a height h, then the power which is required is to actually, in this one, when we are lifting an object h without giving any kinetic energy, because if you are working, then work can change the total mechanical energy. But here we are assuming that there is no change in the kinetic energy, so only the work that you are doing is increasing the potential energy of the system. So we are very slowly lifting an object up. Okay, so whatever work you are doing is increasing the potential energy. Hope you people remember all those pointers now. That work done by external agent is equal to the change in potential energy is equal to the negative of the work done by conservative force. So whatever work is being done by external agent is getting stored in the form of increased potential energy, and per unit time is giving me the amount of power that is delivered by the external agent. Okay. Also, people, we need to define something called as efficiency. Efficiency is the measure of how well the work is being done, how well the job is done. In simple words, if I tell you, say when you are using say ceiling fan, when you are using the ceiling fan, the input power or input energy, can you tell me what is the input energy for the ceiling fan to work? What is the input energy for the ceiling fan to work? Electrical energy, right? And what is the output energy? What is the output form of energy that we want? We want mechanical, or more precisely kinetic energy, right? Everyone, do you think that the total amount of electricity which is being taken by the fan is 100% converted into kinetic energy? Do you think that it is 100% converted into kinetic energy? No. What are the other form of energies which are being produced over there? Definitely heat. Definitely heat will be there. That is why we do greasing and oiling. I hope you people remember a few days back my fan was making sound also. Remember? You guys only noticed it. So that is also a form of energy. So I reduced it by oiling it, by greasing it. But definitely heat is there. Sound possibly is there. And kinetic energy is there. So efficiency is definitely not 100%. 100% efficiency said when 100% of input is converted 100% into output. But otherwise, can I say that efficiency, this symbol that you see, you know, this symbol is pronounced as eta. Okay, the symbol is called eta. It's pronounced as eta. All the random looking symbols come from Greece. They are Greek symbols. Okay, they don't come from India. Definitely in Hindi, eta. Okay, so eta reminds me of one capital of some state in northeast, Itanagar, right? So you can actually remember it like that. Itanagar is the capital of one of the states. Not capital. Itanagar is the capital of one of the states. Arunachal, I guess. Yeah. So it's the capital of that. So anyways, we are deviating once again. Yes, you can say that. So remove th from theta, it becomes eta. Anyways, so eta is the output. In general, efficiency is output upon input. Remember this, into 100. This will give you the answer in percent. When you multiply something by 100, then it becomes percent. Okay, everyone. Otherwise, output by input will only give you the fraction. How much fraction of input energy is converted into output and all that. So remember, this is how efficiency will be calculated. Say if 100 joules of electrical energy is converted into 60 joules of kinetic energy, then eta will be 60 by 100 into 100, that is 60%. So the fan is 60% efficient. Okay, hope you guys are getting it. Input is electrical, output is kinetic, maybe 40% of energy is lost in the form of heat and sound. Good, I hope it is understood. Let's quickly jump to the problems and have a look at the first example. This says that a crane lifts a mass of 100 kg to a height of 10 meters in 20 seconds. Okay, so a crane lifts a mass of 100 kg to a height of 10 meters in 20 seconds. The power of the crane is, I want to give you guys the opportunity to get this easy one. Okay, so throwing this question in front of you all, take it and solve it quickly, giving you only 1 minute, and your time starts in 3, 2, and 1. This is an easy one. You have to assume that only potential energy is gained by the mass, not kinetic energy, because velocity has not been given. So in such case, the assumptions are fair. You can obviously make such assumptions. Okay. Done. Roughly 20 seconds remaining. Okay, and the time is up. Quickly. G value already given as 10, so no confusions there, and really happy. Mogambo Kushwa, looking at the fastest finger list. Very rarely everyone gets it right. So simply the power is going to be mgh by t. Okay, so everything is given. I'll not even solve it for you. It is mass given, G given, height given, time given. So when you simplify this, it is 1000 upon 20. That is, sorry, this is going to be 1000 upon 2, 500 watt. That's the answer. Okay, cool. So congratulations, you got this right. Next question. Now this one says, now this is a really good question. It says that a pump on the ground of a building, on the ground floor of a building, can pump water up to fill the tank of volume 30 meter cube in 15 meters. Okay. If the tank is 40 meters above the ground, then the efficiency of the pump is, and the efficiency of the pump is 30% only, then how much electrical power is consumed? So first of all, you will have to calculate output power, because the information is given for the output power. First of all, what is output? Output is potential energy. You want the water to be lifted up. You want the potential energy to rise. What is input? Input is electrical. Okay, guys. So if we want to find out the change in potential energy, okay. So delta U is going to be mgh minus 0. So the real question is, how do I get the mass of water? How do I calculate the mass of the water? How do I calculate the mass of the water? Nothing is given to me. Only volume is given. What do I do? Density. Does anyone know the density of water? Density of water? It is definitely density rho into volume. Agreed. But what is the density? It is 1000 kg per meter cube, and volume is given as 30 meter cube. So how much mass of the water is lifted? It is 30,000 kgs of water lifted. That's great. So let's calculate the change in potential energy. It is say 30 into 10 to the power 3. G value is 10, and height is how much? 40 is the height. Oh my god, so much of power, so much of potential energy raised. Okay. This step not understood, seriously. So okay, let's take you back to bachpan. We say that density rho is mass upon volume. So can I say that mass will be equal to density into volume? Yes. So density is 10 to the power 3, volume is 30, so 30,000. So this is 3 4s are 12 into 10 to the power 6 joules. This much amount of potential energy is changed. And this much is changed in how much time? 15 minutes is taken. So output power is delta U by delta T. And that is 12 into 10 to the power 6 by 15 minutes. And 1 minute has 60 seconds. So 15 minutes will have 15 into 60 seconds. Understood? How much this value will come? 60 cancels this, or 6 cancels it 2 times. 0 will also take it up. So 2 by 15 into 10 to the power 5. This much is the value that you will get. How much does this come out to be? 20 divided by 15 will be 362 point something, that value comes. But we'll not simplify it yet. We'll not simplify it yet. Okay. So what we have got, power output we have got as 2 by 15 into 10 to the power 5, or I can also write it as 20 by 15 into 10 to the power 4. Chalega? We can write it like this. 5 se cancel karte hain. So we have 4 by 3 into 10 to the power 4 watt. But guys, what is efficiency? Efficiency is output power upon input power. We are being asked the input power, and this is given to us as 30%. It is given to us as 30%. So P in will be equal to 100 by 30 into P out. Is it okay if I write it like this, everyone? 100 comes here, 30 goes down, P in goes to the right hand side. So this is 10 by 3. Output power is 4 by 3 into 10 to the power 4. So this is 40 by 9 into 10 to the power 4. So if we look at the options, they are in kilowatt. They are in kilowatt. So that is 400 by 9 kilowatt. 400 by 9 kilowatt, which is how much? Do the maths. Comes out to be 44.4 kilowatt. Options hai 44.4 kilowatts. इतनी मेहनत तो करनी पड़ेगी. Yes, it is easy and little lengthy. Okay. Yep. So we got this. So, quiz questions for all of you. Okay. This says that an engine pumps up 100 kg of water through a height of 10 meters in 5 seconds. So if the efficiency of the engine is 60%, what is the power of the engine? Okay. So what is the power of the engine is what you have to find out. That means you have to find out the input power. Efficiency is output upon input into 100. You can say. Okay. Input power has been asked. Okay, guys. Giving you all 90 seconds, and your time starts in 3, 2, and 1. Obviously, output power is potential energy per unit time. Output work is potential energy. Input is electrical, which is being asked. 50 seconds remaining. Last 10 seconds. Good, yeah, good, well done. Okay, so everyone, अब मैं directly यहाँ से इसको करता हूँ so that it doesn't look lengthy to you all. Okay, so first of all, efficiency is given to us as 60%. So 60% can be written as 60. You can bring this 100 here directly, or you can say it is 60. And P out is mgh by P in. Okay, into 100. So 60% it is, and P in is going to be, sorry, mgh by T. Mgh by T into 100 by 60. So mass is 100, G value is 10, height to which you are taking is 10 meter, and time taken is 5 seconds. This is 10 by 6. Okay, so 5 will cancel this 2 times, 2 will cancel it 3 times. So here I have kilowatt ke liye, I have 10 by 3 kilowatt, which is obviously 30. So which is obviously 3.33 kilowatt. Answer is option B. Okay, cool. Chalo, one more. Gautam sir, will you be rejoining or you will not be rejoining? Okay, no problem, Gautam sir. No problem. We have two other class teachers. We have Arun sir and Harmeet sir. They will take care of the class. Don't worry. Okay, guys. So next question. What average power is generated by a 90 kg mountain climber who climbs a height of 600 meters in 90 minutes? Okay, so how much power is generated is what has been asked directly. No efficiency. Directly, as a person, when you are doing the work, how much power you are able to generate in lifting your own body, mgh by T, is to be found. Okay, that's what the question is asking you to find out, giving you all 60 seconds, and your time starts in 3, 2, and 1. This is an easy one. Twenty-five seconds more. Last 10 seconds. Time's up. That's good. Very nice. That's an easy one to get. I'm glad that most of you got this also. So mass of the person is 90 kgs, G value is 10, height to which he is climbing is 600, and done in 90 minutes. And every minute has 60 seconds also. So 90 cancelled, 60 cancels 600 10 times. So 10 into 10, 100 watt is the answer here. Okay. Great. Okay. So everyone, this brings us to the end of the chapter. Yes, work par energy ends here, but the class does not end here, because I remember a type of questions which I promised you guys are still pending. So laws of motion, the questions where your rope will also have mass. We'll see those questions today. Okay, so we have a rope which is hanging. Soak in the feeling. We are done with work by energy also, and now we are talking about a type of questions which were not done in laws of motion. So we are looking at those questions. Okay, so pay attention. Question says that you have a rope AB which has a mass m and has a length L. So we have to find out the tension at A, at B, and at the midpoint of the rope. Okay, first let me give you the explanation or solution from common sense point of view. Okay, so everyone, we want to find out how much amount of tension is at A, how much amount of tension is at B, and how much amount of tension is at the midpoint here. So people, if you look at tension as the force which, when we were solving to hold a block like this, the tension in the string was responsible to hold the block and not let it fall. Means what? It was trying to balance the weight of the block which was hanging below the rope. That was the job of the rope and the tension in it, right? So if I ask you again, this is something that we are solving first from common sense, then we'll obviously solve it mathematically. So everyone, if we talk about point B, there is no mass below B. There is no mass of anything, no block, no rope below B. So how much amount of weight is to be sustained below B? At B point, how much weight you want to sustain? No weight you want to sustain. So tension at B should come out to be how much? Should come out to be 0. We'll prove it also. Don't worry. And at A, how much do you think we are sustaining the weight? How much weight we are sustaining? Maximum weight we are sustaining. The entire rod ka weight, entire rope ka weight has to be sustained. So can I say that will be equal to mg, right, everyone? And how about C then? Can I say half of the weight is to be balanced? The weight which is below C point. So answer has to be mg by 2, right? So this is from common sense. Okay, this is coming from common sense, right? Perfect. Now let's try to solve it logically, right? Let's try to solve this logically. Okay, so everyone, when we look at this question, whenever we have any rope, any chain, anything which has mass, which has tension force and has mass also, so whichever point you want to find out the tension, at that point you have to break the rope. You break that rope, and imagine the two portions which are being formed, they are connected by a massless string. Break at the point where we are interested in finding the force of tension. Maybe you are interested in finding the tension here at this point. The random point, take the random point. This right now looks like the midpoint. Let me take it here. This is the random chosen point, which is, say, at a depth x, and here I want to find out the tension T. Okay, so everyone, if the length of the rope is L and this length is x, then definitely the remaining length is L minus x. Okay, everyone. So the equivalent diagram of this thing will be drawn in this manner. That you have a rod. Okay, just a second, that you have a rod, then you have another rod, and these two rods are connected by a massless string. Okay, this is a massless string. So everybody pay attention. If I get the value of tension in this string, that is the tension at this point C, or that is the tension at this point P. Can I say that? At P, at the microscopic level, I am going and I'm considering that there is a massless string which is actually sustaining the two parts of the rope which we are dealing with. Okay, guys. So the only thing now left is if I call the upper portion to have mass M1 and the lower portion to have mass M2. Can I say that this tension force, its job is to balance the weight of M2? Can I say that in the chat box, people? This tension's job is to balance the weight of M2, the lower portion only, right? Okay, good, very nice. So people, I'm about to define something which you have never seen. Okay, I'm about to define something that you have never seen. So please pay attention. Listen to me very carefully. You guys know that the density of an object is defined as mass upon volume, right? Usually this density is defined for a 3D object. This defined as for 3D object, remember. But what if you're dealing with a 2D object? Can you tell me any 2D object? Can you guys tell me any 2D object? Can I say a sheet of paper, a disk, a CD, right? A sheet of paper, right? So try to understand this now. If I'm dealing with a 2D object, for a 2D object, if I want to break the 2D objects, I will break it along the surface. I will not break it along the thickness, I will break it along the surface. So if I break it into half areas, can I say that the two portions will have half mass also? When I break a disk, the two portions have different areas. They have different mass, but they have two things which are still the same. They will still have the same thickness. They will still have the same density, right? Everyone getting it? Yes, uniformly dense. Obviously, we are talking about uniform density. So everyone, what we have defined already is called as volume density for a 3D object. For a 2D object, remember what we are talking about. For a 2D object, we define the surface mass density, or simply surface density, which is called as mass upon area. Why is it so? Because when you are breaking the object, you are not changing the thickness. You're not changing the thickness. Only change is in area, and that brings the change in the mass. Fundamentally, it is density which is mass upon area into length only, or area into thickness only. But this thickness is not playing any role in the changing of mass. That's why we remove that portion. This is done for a 2D object. But what if we are dealing with a 1D object? Like a rod. Like a rod. If I break it, I'll be breaking it along the length. Different portions will have different length, and that length will change the mass. But what is not changing? What will remain same for all the portions is? What will remain same for all the portions is? You're able to see? The area of cross section. The area of cross section will remain the same. If I break it from here, this area will remain same throughout. Do you agree? So this time you define linear mass density, or simply linear density, and you call it mass upon length. Okay. As we move forward in more chapters, we will use these more often. Please remember. Okay. Surface density is also called as areal density. It is also called as areal mass density, surface mass density, but concept is the same thing. Okay. 1D objects have also area, but area of cross section, because 1D objects are also like cylinders. Okay. 2D objects are also cylindrical, you can call them, but cylinders with very less thickness or very less height. And these objects have very good height or good length, but they have very small area. That's it. Nothing else. Here, paper is 2D. Linear objects is 1D. Planar objects are 2D, and ball, cube, cuboid are 3D. Okay. Understood? There is no object which is purely 1D or purely 2D. Actually, everything is 3D. Practically, everything is 3D. Okay. But it is only the negligence that you bring into existence. For a very thin wire, the very thin wire that you deal with, the area of cross section is negligible. You say it is like a line only, right? Like a sheet of paper, the thickness is negligible. So it is only area that you talk about. Okay. Chalo people. So let's go back here. Now, everyone, we are assuming in this question that this is a linear object. So its linear density is assumed to be constant. We are assuming the linear density is constant here. So for this portion, I want to find out the mass of this portion. Sir, any 1D example? इतनी देर से क्या मैं Chinese में बात कर रहा हूँ? And Harmeet sir, can you not give an example for 1D object? So everyone, right now the wire which is there in front of you is the example of 1D object. So everyone, for the entire rod, the mass. Achha, one more thing I forgot to mention: the symbols. The symbol that you will usually use for volume density. The symbol will be rho. The symbol is called rho. You guys are aware about it. Surface density. The symbol is called sigma. This is called sigma. And for linear density, the symbol will be lambda. Will these symbol ever be used for any other quantity? Yes. You will find lambda be used for wavelength. You will find sigma be used in thermodynamics also. You will sometimes be using rho as resistivity also in the chapter of resistance. And this will happen many times in physics. That one symbol will be used for multiple physical quantities, but not in the same chapter, not in the same unit. So you will understand it by the language of the question that what is this symbol representing right now. Okay. So no confusions, no debate, no argument over it. Okay. Cool. So right now the linear mass density lambda, for the given rho is mass of the entire rope divided by the length of the rope will be equal to mass of the portion which is hanging, that is M2, divided by the length of that portion, that is L minus X. This will also be equal to M1 divided by X. Do you guys get this part? This is what writing the density means. Okay. Achha, by the way, if you guys are not convinced completely, this is that rod, and let's say its area of cross section is A. So let's write the normal density as you always write. Let's write down the normal density. Rho. So maybe the area of cross section is A. Can I write down the volume of a cylinder as A into L? Can I write it like this, everyone? Volume is A into L, correct? So let's write that down. For every portion, you will write down the same thing. Do you see that A is getting cancelled in all the three? That's the only factor which is common. And that's why we define linear mass density. Okay, people? So again, taking you back to the linear mass density, lambda. So what do I want? I want only this part. Why? Because I'm sure from here that T is equal to M2G. So if I get the value of M2, my problem is solved. Okay, and then I will be answering part 1, 2, and 3. So from here, everybody, M2 comes out to be capital M into L minus X divided by L. So the force of tension is equal to M2 into G, which is capital M by L into L minus X into G. So the tension comes out to be mg into L minus X divided by L. Okay, this is what we are getting. Or if I write it even better, this is how we'll represent it. This is the tension force which I'm getting in the form of X, the variable. Now you will see all the three answers coming one by one. Okay, so let's find this out. This is the rod that we are dealing with. This is hanging from here, and this point is A, this point is B, this point is C. We have got tension as capital Mg L minus X by L. So at A, at B, and at C, X ka value, X ka value, and X ka value. So people, what is the value of X at A? We started measuring X from the top, by the way. We started measuring X from the top. So from the top, X is equal to 0. So what is the tension that we should get? Put X equal to 0 here. Put X equal to 0 here. What will we get tension as? Tension ka value comes out to be mg. This is TA. Okay. Put X equal to 0 here. Sorry, X equal to capital L. At B, this is X equal to L. Agreed? So what are we getting TB? TB kitna aata hai? This comes out to be 0 because L minus L will be equal to 0. Hope you guys are following this. We are just putting these values of X here. This column is being put here. That's all. Now put X equal to L by 2. How much TC you are getting? Mg by 2 aata hai, right? And that is what we got from common sense. Mg 0, Mg by 2. Got it? Definitely common sense ज़्यादा easy लग रहा था, but trust me, you really want to learn the approach of science, the approach of physics, because as you move forward in physics, not common sense will be very easily applicable. Okay. One more thing, guys. You people remember I said when your rod or rope is considered massless, when it is considered massless, the tension throughout is same. The tension throughout the rope is same, right? But now, as the rope also has mass, you can see the tension at different points is coming out to be different. It's different at different points. Understood? Tension is changing. Okay, cool. So let's look at one more question quickly. Yes, definitely you should watch the replay of this part. This time, this is the top view of a rope which is placed on the ground, or chain you can say, and it has been pulled horizontally. This is pulled horizontally by a force F. Question is again asking you to find out the value of the tension at A, B, and C. Okay, that is the midpoint. So once again, guys, we will approach it in the same manner. We'll approach it in the same manner. We'll not go by common sense. We'll directly go by the approach which we want to apply here. Okay. So first of all, the entire rod will have the same acceleration. That acceleration will be equal to total force which is acting divided by the mass of the rope, that is capital M. And what I'm going to do, I'm going to consider at a distance X, I have to find out the tension here. So the remaining length is L minus X from here. So I'm measuring it from the right end. You can also start from left hand, not a problem. But you have to remember from where you are measuring. Okay. So usually you measure from the point where the force is acting. So from A, the force has started acting. So to the left hand side we have 1. And this diagram can be redrawn in this manner. This is what it is. So this is M1, this is M2, and the tension force is acting here. Okay. Guys, can I say that the job of tension is to pull M2? The job of tension is to pull M2. If you will draw the free body diagrams, you will easily be able to solve it as the two block system. The two block system says that this is tension T, this is acceleration A, and this is M2. So we will say that tension is equal to M2A. So if I get the value of M2, I am getting the answer very easily. And you already know how to find out M2. Okay. Yes, obviously. If you want to talk about anybody ask for the leaderboard in the chat box is getting blocked now. Try. Anybody asking for the leaderboard gets blocked right away. So everyone, again, the linear mass density lambda is total mass upon total length. M2, the mass, and the length is L minus X. Getting it? I'm not writing for M1 because I directly get it for M2 as M L minus X. Do not remember it. Do not try to memorize what I'm doing. I'm just asking you to understand what I'm doing. Okay, everyone. Now put this here to get the value of tension. Everyone. So tension comes out to be, the tension comes out to be M into, or rather I'm solving M2A. So it is M L minus X by L into A. That's basically what we are getting so far. Okay. So guys, I have got tension. This is X. This is L minus X as M L minus X by L into A. And what was the acceleration? Acceleration was total force acting divided by the total mass. Obviously, answer cannot be in terms of A. A is something that we have written in the question. So L minus X by L into F by M. M gets cancelled. The tension comes out to be F L minus X by L. You were measuring X from the left hand side, right? So tension at A when X is equal to 0. Tension at B when X is equal to L. And tension at C when X is equal to L by 2. So this will come out to be when you put it 0. It's the entire force which is acting as the tension force for the entire rod. The entire rod is being pulled by this force only, right? Then at B, there is no mass to be pulled from here. There is no mass to be pulled here. So definitely the tension when you put X equal to L will come out to be 0, right? And when you put X equal to L by 2, the tension at C will come out to be F by 2. Similar approach, but this time in the horizontal direction. Okay, everyone? Got it? Do watch the replay of last half an hour. You will understand this. Yes, definitely. Thank you. So this brings us to the end, and this is finally the leaderboard. Okay. Yep. So we are done for the day. Okay. And here is your daily dose of Rocket Man. So Sir, I follow you on YouTube. Thank you. Thank you so much. So which software they use to get on the top rank, sir? Whichever software they use, it might work in this class in Vedantu's platform. It will not work on the day of JEE examination. So you don't have to worry. Okay, sir, I follow you on Instagram. Thank you, sir. What is the symbol of what? What is the symbol of what? What is the symbol of T? दो चीजें मत पूछना एक कि सर नोट्स कैसे बनाऊं, दो कि सर मेरे से ना सिलेबस नहीं हो रहा है, मेरे से पढ़ाई नहीं हो रही है। ये दो चीजों के अलावा कुछ नहीं। हाँ हाँ इज इक्वल टू 1। मैंने कराया ये जब हमने वेक्टर्स पढ़ाया, 3D वेक्टर्स जिस दिन पढ़ाया था। सो इन द सेशंस ऑफ वेक्टर्स यू विल फाइंड दिस प्रोबेबली ऑन सेकंड सेशन नंबर 2 यू विल फाइंड द प्रूफ ऑल्सो, वहां कराया मैंने। ठीक है, ओके। हाँ, डायरेक्शन टू साइंस, यस गाइस, क्लास इज ओवर, क्लास टीचर्स, इफ योर डाउट्स आर डन यू कैन आल्सो एग्जिट। सर अनम्यूट मी एज वेल, जस्ट अ जनरल डाउट। ठीक है, यस मानव, यस टेल मी। That's basically that's this is definitely wisdom. This is definitely wisdom. So I remember one incident when I was doing an internship. So after third year of your engineering, in the third year of your engineering, you're supposed to go for an industrial training. Okay. So in that industrial training, I was a metallurgical engineering student. So my industrial training was in Mumbai only, and I don't remember the name of the company, but the company makes furnaces. They make furnace in which you put the objects and you heat them. So the person who was heading that company, he was an ex-IIT Bombay alumni only. So one day we were just chatting, so he told me at that point of time that an engineer is not a person who will look at the data and then figure out a conclusion. An experienced engineer is a person who will be able to say for a flowing water from a tube, if he touches the water, just the flow of the water, and he touches it, will be able to tell you what is the flow rate of the water by just the touch of it. That's what experience is. So when you talk about, actually this is not about physics. Physics will only guide you with the mathematics of it. It is the experience in the industry which what you are talking about and what I am talking about that experience of that person. These are the specific experience of a specific field in which you work for a long time. Like I tell you, cricketers when they ball and they bat, the batsman who's batting, if he's an experienced one, he'll be able to figure out at what speed the ball precisely is coming or roughly is coming at. So that is their experience. It's not that they have done some kind of mathematical calculation in their mind. They understand how it feels when the ball comes at a speed of 150 km per hour or when it comes at 160 km per hour. Totally wisdom. Totally wisdom. Okay. Okay. Sir, will you invite to your home for a party when we have cracked JEE main or advanced? I don't know whether I'll be inviting you, but definitely Vedantu will. Okay. Sir, got 97 in physics because of your videos. Thanks. Congratulations, yeah. Well done. I'm glad. So tips for phase 1. What is phase 1? Are we launching anything? Oh yes, Samagita. Yes, Samagita. First slide, the second topic. Okay. Just a second. This one. So whenever work is being done, it is equal to the change in total energy, right? Work is being done by us, and we are not conservative force providers. We are external agents. So when we are working, when machines are working, they're not applying conservative force. Conservative forces are applied by gravity, by electric field, by magnetic field. So whatever work is being done by a machine, done by us, that work will change the mechanical energy of the system. And mechanical energy is kinetic plus potential. So effectively, work is going to be changing potential plus changing kinetic energy. But unless anything has been mentioned about the velocity of the body being changed, you will always assume that the kinetic energy of the body is not changed when doing that job. Specific type of questions where the object is being lifted. In those questions, like this one itself, a crane is lifting a mass of 100 kg to a height of 10 meters in 20 seconds. Definitely, when the crane will lift, it will take some velocity. It will give some velocity to the object also. But we are assuming that it's a negligible amount. So mostly the work is being done to lift the object, to give it kinetic, to give it potential. Exactly. So we are assuming that part is negligible because question is not giving us any data about the velocity. If it will, we will use that part also. Then we will actually calculate mgh by t plus kinetic energy by t also. Then we'll solve it as total mechanical energy per unit time. Good, great. Right. Just a second, Tushit. Let me unmute Aman first. Then your number. Yes, Aman. Yes, Arun sir, you can leave the session. Aman, right? Aman, see, always and always remember, in one day, we have 24 hours. In that, you have multiple activities to do. The major activities involve 7 hours of sleep. How many hours of schoolwork or school? Including your traveling, you have to tell me. So 8 hours of school. Okay, and say 5 hours of your own life, 4 hours of life. Yeah? When I say life, you have your personal routine, you have your eating, spending time with your family, watching some TV, or doing some time pass. That is all life, right? So how much hour has already gone here? 7 plus 8 is 15. 15 plus 5, 10 gone. 4 hours. And how much you spend on Vedantu? The time? Every day? So roughly 3 hours on an average. So 3 hours every week point of view, right? So basically, you'll have to cut down your time from your life. This is the time that you'll have to. When they say sacrifice, this is what it is. Sacrifice happens here because other times are actually non-negotiable. You can't negotiate. So if you talk about this, already 18 hours are gone. I'm sure at least 7 hours तो सोना ही पड़ेगा ना हमें. नहीं चाहिए. 6 to 7 hours की नींद होनी चाहिए. So definitely the entire game will revolve around these 5 hours. तो ये 5 आवर्स को तुम कितना स्मार्टली यूटिलाइज कर रहे हो। अगर यहाँ से तुम 2.5 to 3 आवर्स स्पेयर कर पाए खुद के लिए, स्टडीज के लिए, एक्चुअली सेल्फ स्टडी, तो आई वुड से इट इज अ गुड जॉब। एंड देन जो भी डेफिसिट बचता है उसे संडे को कवर कर लो। बट दिस स्ट्रगल इज देयर इन एवरी जे एस्पेक्ट्स लाइफ, दैट इज व्हाई देयर इज अ कांसेप्ट ऑफ डमी स्कूल आल्सो। ओके, हाँ, सम पीपल स्लीप फॉर 6 आवर्स आल्सो, बट नॉट लेस देन 6 आवर्स। मिनिमम नंबर ऑफ आवर्स यू शुड स्लीप इज 6। ओके, ठीक है अमन, तो मैं और कुछ रॉकेट साइंस नहीं बता सकता, जो टाइम है वो टाइम है है ना। ओके सर, कैन यू शो स्लाइड वेयर द आंसर वाज 3.3 किलोवाट। आता है, चलो 3.3 किलोवाट वाला ये था शायद। लो भैया, यस तुषित, योर टर्न। यस तुषित, स्लाइड 37। ओके, स्लाइड 37 is it? Yes. Hmm. It is changing, yes. By which factor it is changing, we are not concerned about that. I don't know, but yes, they continue. Hmm. 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 So finally, you will find out velocity as a function of time, right? So that is what it is. Eventually, that's what you did. That's what you did here. Look at this. My velocity as a function of time. That's what is my job. We want to find out velocity as a function of time. वो मैसेज भी आएगा, बिल्कुल बिल्कुल आएगा, बिल्कुल आएगा। ये वाला जो अप्रोच था ना, दिस अप्रोच, यू विल गेट दिस फ्रॉम दिस अप्रोच आल्सो। यस, डेफिनेटली, नो डाउट। ओके, हाँ राइट, सामने तुम्हारे सामने स्क्रीन पे सामने क्वेश्चन क्या नहीं समझा वो पूरा सवाल नहीं एक्सप्लेन हुआ दोबारा से। फॉर दैट आई आस्क्ड यू टू रीड। क्या नहीं समझा वो बोलो, ये देखना, बिकॉज़ मैंने दो बार एक्सप्लेन किया है जब भी पढ़ाया था। ठीक है, एंड माय सजेशन, व्हेन यू स्टडी, व्हेन यू टेक वन ऑफ क्लासेस, सिट इन अ रूम वेयर यू आर अलोन। ओके सर, व्हाट इज डमी स्कूल? नो कमेंट्स, आस्क योर सैम। बेटर यू आस्क मी हियर। कैन यू, यू स्पीकिंग एक्सट्रीमली लाउड, कैन यू प्लीज स्पीक अ बिट सॉफ्टर, सिक्स मोर सॉफ्ट, ट्राई टू विस्पर। व्हाट्स द डिस्टेंस बिटवीन यू एंड द माइक राइट नाउ? 1 feet. That means there is a scope of reducing that gap. किस चीज का सिंबल पूछ रहे हो, इसीलिए अनम्यूट किया तुम्हें। क्या? हाफ पाए? अरे चैट पे तो नहीं समझ आ रहा है तुम क्या बोलना चाह रहे हो, इसीलिए तो अनम्यूट किया तुम्हें। अच्छा, ये इस सिंबल को क्या बोलते हैं? ये है वो सिंबल। हाँ, कहाँ देखा ये सिंबल तुमने, कौन से क्वेश्चन में? हाँ, काइनेमैटिक्स में सिंबल आया। अच्छा ठीक है, ये है वो सिंबल, टाउ बोलते हैं इसे। ओके, अरे क्यों नहीं करेंगे यार, तुम्हें तो जरूर अनम्यूट करेंगे। हाँ सुधीर, हाँ सुधीर बोलो। यार एको आ रहा है बहुत। हाँ ठीक है, कर लेंगे, सहन कर लेंगे थोड़ा, सहन लेंगे थोड़ा, बोलो। डेल्टा डी बाई डेल्टा टी का क्या? यार पावर की डेफिनेशन क्या है, पावर का मतलब क्या है कि एग्जैक्टली exactly. तो अगर मैं कितना अमाउंट ऑफ वर्क हो रहा है, कितने टाइम में हो रहा है, तो उसको मैं कैसे लिखूंगा? टोटल अमाउंट ऑफ वर्क डन, टोटल अमाउंट ऑफ टाइम चेंज। तो ये हमने डिफरेंशिएशन वाले फॉर्म में लिख दिया बेसिकली, और कुछ नहीं। ठीक है भाई, तुम डब्ल्यू बाई टी लिख लो, कोई दिक्कत नहीं है। अंडरस्टैंडिंग हैज टू बी क्लियर। ठीक है, वो है इंस्टेंटेनियस पावर। मतलब अगर मान लो मैं बात कर रहा हूँ एक बहुत छोटे फ्रैक्शन ऑफ टाइम के बारे में, तो उसमें होने वाला वर्क जो है वो छोटा सा वर्क होगा, विच वी कॉल एज डब्ल्यू। ये अंडरस्टैंडिंग आती है डिफरेंशिएशन के चैप्टर से। ओके, हाँ हाँ, ये कहाँ से कॉल कर रही है? ठीक है, हाँ, अर्थ के, अभी तुमने बोला अर्थ हमारा फ्रेम ऑफ रेफरेंस है। हाँ, ये लॉ ऑफ मोशन का क्वेश्चन कैसे हुआ? क्वेश्चन तो वर्क पार एनर्जी का लग रहा है। तो एक बॉल है तो नीचे गिर रही है, राइट, और तुम यहाँ कहीं मून पे हो, तुम ऑब्जर्व बॉल को कर रहे हो, तो अर्थ तुम्हारा सिस्टम कैसे हो सकती है? अर्थ और बॉल दोनों मिलकर सिस्टम बनाएंगे ना। हाँ, तो अर्थ की वजह से लगने वाला जो फोर्स है वो इस बॉल पे लग रहा है। ठीक है, क्वेश्चन क्या है? किसकी वजह से, ये भी तो पूछो, किस वजह से? बिल्कुल हो रहा है। यहाँ से देखने पर, यहाँ से देखने पर क्या इन दोनों के बीच का ये जो गैप है ये कम होता हुआ दिख रहा है या नहीं दिख रहा है? बस तो फिर फोर्स लग रहा है, डिस्प्लेसमेंट हो रहा है, तो वर्क डन बिल्कुल हो रहा है। हाँ, इंटरनल फोर्स है बिल्कुल। अर्थ प्लस बॉल के सिस्टम पे वर्क नहीं हो रहा है, लेकिन बॉल पे वर्क हो रहा है, अर्थ पे भी वर्क हो रहा है। अगर ऐसा देखो, देखो अर्थ, ऐसे में अज्यूम करना पड़ेगा सबसे पहले तो कि अगर अर्थ ने बॉल पे फोर्स लगाया mg डाउनवर्ड, तो बॉल ने भी तो अर्थ पे फोर्स लगाया mg अपवर्ड। ठीक है, तो ये जो दोनों फोर्सेस हैं ये इफेक्टिवली दोनों बॉडी को इफेक्टिवली क्या बोलना चाहिए, दोनों ही बॉडीज इफेक्टिवली अपने एक दूसरे की तरफ मूव कर रहे होंगे। और ग्रेविटेशन में भी चैप्टर में पढ़ेंगे भी कि जब दोनों बॉडीज पे फोर्स लगता है तो दोनों ऑब्जेक्ट्स मूव करते हैं। ये h1 डिस्टेंस ट्रैवल करेगा, ये h2 डिस्टेंस ट्रैवल करेगा, ठीक है। तो जब तुम कैलकुलेट करोगे वर्क डन बाय दिस फोर्स अप्लाइड बाय अर्थ ऑन द बॉल, तो उसका वर्क कैलकुलेट कर लोगे, और जो mg ने वर्क किया फॉर द अर्थ, अर्थ पे लगने वाले फोर्स ने जो वर्क किया वो भी कैलकुलेट करोगे। तो इफेक्टिवली ये दोनों ही वर्क इंटरनल फोर्सेस के वर्क होने की वजह से हम बोल सकते हैं कि ओवरऑल देयर इज नो चेंज इन द एनर्जी ऑफ द सिस्टम। मतलब आगे जाके हम ये पढ़ेंगे कि अर्थ और बॉल का जो सिस्टम है उसमें लगने वाला फोर्स सिर्फ एक ही फोर्स है, और वो है ग्रेविटेशनल फोर्स, है ना। और ग्रेविटेशनल फोर्स क्या है? कंजर्वेटिव फोर्स। तो जब भी कंजर्वेटिव फोर्स वर्क करेगा, अगर मैं उसे इंडियन काइनेटिक एनर्जी के बराबर लिखता भी हूं, तो ये फोर्स जो गेन कर रहा होगा वो किसके एक्सपेंस पे आ रही है, मतलब काइनेटिक एनर्जी कहां से रही है? पोटेंशियल एनर्जी कम होने की वजह से। जैसे जैसे बॉल की आएगी, अगर रियलिस्टिकली बोले तो नहीं करेगी, क्योंकि वो ऑब्जेक्ट जो तुम बात कर रहे हो वो अर्थ के साइज से बहुत छोटा है। अगर हम बात कर रहे होते मून और अर्थ की, तो डेफिनेटली अर्थ भी मूव कर जाएगी। लिखते हैं ना डॉट प्रोडक्ट के फॉर्म में, वर्क इज अ स्केलर क्वांटिटी व्हिच इज रिटन एज द डॉट प्रोडक्ट ऑफ टू स्केलर वेक्टर्स। फॉर्म में लिखते हैं इट कैन बी ऑब्टेन्ड फ्रॉम टू वेक्टर क्वांटिटीज। हां, ओके गाइस। Lakshya trying to unmute you but not working. Yes, Hridaya, slide with 1800 वाला. Wait a minute. Yeah. Lakshya Pandey, bacha trying to unmute you, not happening. Sir, work done by pseudo force. We didn't say that moon is a non-inertial frame of reference. That's why we did not use any pseudo force there. Okay. Can you please show slide number 63? 63 is this. Okay. Nikhil, you know that you get this as the PDF of the session, right? Still the same problem, Lakshya. This is what is happening at my end. If you are able to see this, Lakshya. Sir, I do NCERT questions, assignment questions, and do all the questions of exercise 1 and try to solve exercise 2. But sir, मुझे लगता है कि अभी मेरा चैप्टर कंप्लीट नहीं हुआ. That I'm not satisfied. So sir, what I have to do? Harshita, have you spoken to me earlier also? Lakshya, you can ask a question in the chat. Harshita, have we spoken like in the last class or last to last class? By unmuting you, I think I've given you fair enough idea about what you should be doing. And this is precisely what we spoke about. When you are solving exercise, don't solve questions 1, 2, 3, 4, 5, 6, 7, 8. Solve it as question number 1, question number 4, question number 8, question number 12, question number 16, like that. You will be able to reach to the end of this exercise. Sir, Tattu ka question hai, work done by pseudo force, positive, negative, zero, all of these. Shashank, all possibilities are there. Shashank Raj, all possibilities are there. Work done by pseudo force. It can be positive, can be negative, can be zero. Sir, I'm in a dummy school, so what are the minimum hours I should give to self study, and especially for physics, or like I kind of find it difficult. यार संकेत, अगर बात करूं तो जैसे उसी का एग्जांपल ले लेते हैं यहाँ पे, तो the amount of time that he was giving for the school, you should give it for your studies. That's it. So I would say apart from Vedantu classes, you should be able to dedicate 10 hours for yourself. Okay. So that part where we had written m2 by m by l, m2 by minus, I did not understand why they are equal, because they are densities. ये पार्ट समझ में आया था तुम्हें लक्ष्य? ये बात समझ में आई थी? तो अगर मान लो मैं इसके पूरे मास को लेंथ से डिवाइड करता हूँ, तो ये है लीनियर डेंसिटी. दैट्स व्हाट इट इज, लीनियर डेंसिटी. लक्ष्य, राइट? सो इफ आई वांट टू राइट इट फॉर अ स्मॉल पोर्शन ऑफ लेंथ x and whose mass is m1, should it not also be valid for that portion, the density? What is density? It is this, right? Mass upon length. And the remaining portion, l minus x, has mass m2, so that is m2 upon l minus x. That's what we are writing. Make sense? Okay. So I got 975 in physics because of my rude physics class teacher. That's okay. These marks of 11 standards are any which way not going to serve any purpose. Okay, so don't worry. 10th class also won't matter. So don't worry. Be happy. Okay, relax. This is not the last examination. Forgive your teacher. Congratulations, Arpita. Congratulations. Much better than mine. Bye-bye, Stephen. Bye-bye, Ananya. Absolutely, Sanket. Absolutely. Sure. और नेक्स्ट टाइम अनम्यूट करवा लेना, बात कर लेना मुझसे एनी विच वे, ठीक है? और इस बार फीडबैक में सूरी सर ओपी मत लिखना. Yes, good night, Arpita. Bye-bye. 86% in ICSE. That's good, yeah, that's good. Anything which is above 77.8 is good for me. है ना? Okay, Sanket. I wasn't lying. My actual percentages were 77.8 only. Why would I lie? No, I'll have dinner now. You got 91%. Why do you guys want me to feel bad about my 10th standard? Sure then, everybody. We'll meet, I guess, next week now. Our class will be on next Monday. So we'll meet and we'll start a new chapter. Okay? Sure. Let's sign off. And Shashank, yaar. Chalo, bye-bye. Good night, everyone. Bye-bye. Hasta la vista. Take care. Signing off.